All right, so we're now going to take a look at the fundamental counting principle. The very first example actually does not explicitly use the fundamental counting principle, it just kind of reviews the concept of a tree diagram. So we have the sandwich cart, and they offer you the choice of hamburger, chicken, or fish. Okay, so if I draw a little diagram here, here's a little fishy, here's a little chicken, and the hamburger, we'll attempt to draw a little bit of a cow here. Moo. Kind of looks more like a pig. Anyways, so we also have the option of either a plain bun or a sesame seed bun. So here is my plain bun, and here is my sesame seed bun. Okay? And in the tree diagram, what we see is the fish can be paired with the plain bun. So we have a fish plain bun option. The fish can also be paired with the sesame bun, giving me a fish sesame option. We'd also have chicken with the plain bun, giving me a chicken plain option. And the chicken can go with the sesame, giving me a chicken sesame option. Lastly, we could have a hamburger on a plain bun. And we could have a hamburger on a sesame bun. And in total, we have 6 different possibilities of a choice of meat and bun at this sandwich cart. All right, the next scenario, we have this radio contest where you can have a prize of a restaurant gift certificate and tickets to a sporting event. So notice your prize, you have a restaurant gift certificate and a sporting event. So there's technically 2 prizes here, okay? So first prize, the restaurant. We have 3 different restaurants. And then for the sporting event, we have football, baseball, basketball, or hockey. So there are 4 different options. So by the fundamental counting principle, we can multiply these to find that there are 12 different possibilities of selecting a restaurant followed by a sporting event. I just want to point out one of my strategies here. I really like to use placeholders. That way I can kind of set up how many different options I have within each category. Alright, so now I have an answering machine, and we are entering a 3-digit code. The 3-digit code is going to be the 3 different placeholders that I have. Now the possible digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Basically, these are all the buttons on your cell phone. So there are a total of 10 different digits, okay? And because it doesn't say that I can't repeat them, I can assume there's 10 different digits to plug into each of the 3 different digits, okay? And so we just multiply that by the fundamental counting principle, and 10 times 10 times 10 is a total of 1,000 different codes, okay? Last example, we have this Charlita who's going to take 6 different classes. So one way of starting to look at this is we have 6 different placeholders, one representing each of the individual classes. So like a first period, a second period, a third period, a fourth period, fifth, and sixth period class. Assuming that each class is offered during a period, how many different schedules could she have? So during her first period class, she has 6 different options. Now in her second period class, she only has 5. If you think about it, are you going to take English 9 both first and second period? No. So the number of class options she has is going to decrease throughout the day. And so this expression can actually be represented as 6 factorial. 6 factorial simply means 6 times 5 times 4 times 3 times 2 times 1. So 6 multiplied by all the numbers beneath it. So this gives us a grand total of 720 different possible class schedules.